Good morning, good afternoon, or good evening, and welcome to another video tutorial. Today's topic is solving one or two-step inequalities or multi-step inequalities. So get out a composition book, get your pencil out, pen, and let's take some notes. Okay, so anyway, this is an inequality. Why? Because it has, this less than symbol. It has that less than symbol, okay? But solving inequalities, one-step, two-step, multi-step inequalities is very similar to solving an equation. What do you mean? Well, if I change this problem to just 2x plus 4 equals 7 plus 2, all right? So all I've changed was that sign. I went from a less than sign to an equal sign, okay? Well, if I asked you to solve this equation, the very first thing you probably would do is combine your like terms. You would probably combine 7 plus 2. Then the next step, you would eliminate that constant. Let's subtract that 4. And then you would divide by 2, right? I have 2 times what is 5? We'll do the opposite, divide by 2, divide by 2. And you get x equals 2 1/2, all right? So solving this inequality, you're gonna follow the exact same process. So here are the steps, and just like we just discussed, the very first thing you should do when solving inequalities is simplify. Combine your like terms. Step number 2 is eliminate your constants. Let's get rid of anything that says add 7. Subtract 3, those because that 3 and that 7 is a constant. And then step number 3 is to eliminate the coefficient. That means anything like 5 times 3 or 5x or 3x or multiply or divide. Okay, kind of got a little tongue-tied there, sorry about that. But go ahead and just press pause and let's write this down. So in this problem, what would I do first? Well, let's just combine all your like terms. So I would combine this 2x with this x, which would give me 3x. I would also combine this plus 7 with this plus 2. And so I would bring this down, plus 6 is less than 9. 7 plus 2 is 9. I brought the 6 down. All right, now let's eliminate that constant. You have a plus 6, so in algebra, you always do the opposite. The opposite of adding 6 is to subtract 6. So let's now subtract the 6. Subtract the 6. And so now my new inequality would be 3x is less than 3. And then how do you eliminate 3 times a number? Well, divide. Divide by that 3. So if I divide by 3 here, that's going to cancel because remember that x is a number. Anything multiplied by 3 and then divided by 3 is that number. Yes. So you have the number, but then you got to divide by 3 here. And so your final equation or inequality is x is less than 1. So we're saying, now remember, x is not just a number. X is a multiple of numbers. We're saying in order for this inequality to be correct, x must be smaller than 1. Well, what could we do to verify if this is correct or not? What could we do to verify if this really works, that x is less than 1? Yeah, pick a value for x. And I would always pick the simplest number there is, which would be 0. Use 0, because is 0 less than 1? Is 0 less than 1? Yes. So let's plug in 0 here. Let's just see if this statement is true. Let's put 0 here. We'll put 0 here. And is this true? Because we know over here we have 9, right? So is all of this less than 9? Well, yeah, because you got 2 times 0, 0, plus 6, 6, plus 0, we get 6. We have 6 over here. We have 6 over here. Is that less than 9? And the answer is yes. So you still can verify. When you solve these inequalities and your answer, if your answer says x is less than 5, okay, well, pick a simple number. I would always use 0 or 1, okay? And then plug it in and just see if that statement's true or not. So here's all I want you to do. I want you to solve these 3 problems. Notice I got the stars. Number 1, number 2, it gets a little harder, and number 3, okay? And then number 4, I have made a math wizard problem. And this is optional, but this will be added to your Math Olympiad score if you solve it correctly. And we'll discuss it tomorrow, okay? So that's the end of the video tutorial. I know it's short, it's sweet, it was 5 minutes long. Hope you enjoyed it, and I will see you tomorrow morning.